Welcome back, inventors! Let's start with a simple experiment. Take your phone and turn the screen brightness all the way down, then all the way back up. Pretty cool, right? But have you ever wondered how the screen becomes brighter or dimmer? Here's the surprising part. The tiny LEDs inside your screen aren't actually receiving less power. Instead, they're using a clever trick. Today, you're going to learn that very same trick. It's called pulse width modulation, or simply PWM. By the end of this lesson, you'll understand how it works and build your own LED brightness controller using Arduino. Now let's think about something. A normal light switch has only two positions, on and off. Arduino's digital pins work exactly the same way. They only know two states, high or low. So here's the big question. If Arduino only understands on and off, how can it make an LED glow softly instead of shining at full brightness? Take a moment and think about it. The answer is much smarter than you might expect. Here's the secret. Imagine turning a light switch on and off hundreds of times every second, so fast that your eyes can't possibly see the blinking. Instead of seeing the light flash, your brain blends all those tiny flashes together into one steady light. Now imagine the light stays on for only a short amount of time during each tiny cycle. The LED appears dim. If it stays on for longer, it appears brighter. And if it stays on the entire time, the LED shines at full brightness. This is called the duty cycle. The duty cycle simply tells us how long the signal stays on during one complete cycle. So remember this important idea. PWM doesn't change the voltage. PWM changes the time. By changing how long the signal stays on, Arduino creates the illusion of different brightness levels. It's a simple idea, but it's one of the most useful techniques in electronics. Now, not every pin on an Arduino can create PWM signals. On the Arduino Uno, only the pins marked with a small tilde symbol, that's this little squiggly line, tilde, support PWM. These are pins 3, 5, 6, 9, 10, and 11. For today's project, we'll use pin 9 to control our LED. Now let's make Arduino control the brightness. We'll use a potentiometer, which is simply a knob that you can turn. As you rotate it, Arduino reads a value between 0 and 1023 using the analog read function. But there's one small problem. The analog write function only accepts values between 0 and 255. So how do we convert one range into another? That's where the map function comes in. Think of map as a translator. It takes a value from one range and converts it into another range that Arduino understands. Once the value has been converted, analog write uses it to adjust the PWM signal, changing the LED's brightness smoothly as you turn the knob. Almost every sensor project you'll build follows the same three-step process. First, read the sensor. Next, map the value if needed. Finally, write the output. Read, map, write. That's a simple pattern you'll use again and again throughout your Arduino journey. Now it's time to build your project. Connect the potentiometer to A0. Connect the LED through a 220 ohm resistor to PWM pin 9. Upload the program and slowly turn the knob. Watch as the LED smoothly changes from dim to bright and back again. You're not changing the voltage, you're changing the duty cycle, and that's PWM working its magic. What's even more exciting is that this same technique is used all around you. Phone screens use PWM to adjust brightness. Smart lights use it to create smooth lighting effects. Gaming keyboards use PWM to control colorful LEDs. Laptop cooling fans use it to change their speed. Even robots use PWM to control motors and movement. Today, you've learned the same technology that engineers use to build real electronic products. Fantastic work! Today, you discovered how Arduino creates different brightness levels using pulse width modulation. You learned what the duty cycle is, why only certain Arduino pins support PWM, and how analog read, map, and analog write work together to control an LED. Most importantly, you built your very first LED brightness controller. Take a moment to celebrate what you've achieved today. In our next lesson, we'll use everything you've learned to control the precise movement of a servo motor and build an automatic barrier gate. Until then, keep experimenting, keep building, and most importantly, keep inventing.